everybody. Today we are going to be learning about domain and range of a function. Let's go. Before we head into today's lesson, we're going to do our check-in. And so the check-in question for today is, what is your top silly fear or phobia? Mine is, I have a fear of dog bites. At some other time, I'll tell you the story that led me to have this fear as a lifelong thing. Yeah. So let's get into our launch for today. Let's see how much you recall from your previous lesson. So here is the first question that we're looking at. And it says, on what intervals is this function increasing? All right. So if we look at this graph, we can clearly see, remember that a function increases when, as the x increase, the y increase. So if we're looking at this, we can clearly see the function increasing from -7 to 5, and we're also seeing it increasing from -4 to 3. So as our x values increase or y values increase, which means they're getting bigger. So this would be A and C. All right, so let's look at this contextual problem. It says Alan started a new exercise program on his treadmill. The graph shows his heart rate on one of his 40-minute workout routine. On what interval is the function decreasing, and what does it mean in this situation? So remember, a function decreases if we notice as x increases, the y or the output value is decreasing or getting smaller. So we can clearly see what that interval is on the graph. It's right here, and it's looking at from 30 to 40. So in this particular situation, in the interval on which a function is decreasing is from x is equal to 30 to x is equal to 40. In this case, it means that Alan's heart rate started slowing down between 30 and 40 minutes of exercise. So as we can see, at 30 minutes, Alan's heart rate was 110 beats per minute, and at 40 minutes, his heartbeat was 70 beats per minute. Now, today, we are learning how to identify the domain and range of functions, so let's go. We're going to start off by looking at the definition for the domain of a function. So the domain of a function is a set of all possible input values. Now, remember, our input values are the same as x values, so in this table, input values would be from -4 to 6. So it would be -4, -2, 0, 2, 4, 6. So our domain is a set of all possible input values that are in the function. So in this table, they would be -4, -2, 0, 2, 4, and 6. What is the domain of this function? It's represented as a graph. So remember, as we defined initially, the domain of the function is going to be the set of all possible x values. So what would that be? The possible x values on this graph would be from -4 to +5. Therefore, the domain of a function is the set of all possible input values. So in this graph, the domain is a set of all values of x from -4 to 5. What's the domain of this function? Okay, so if we think about the definition, the domain is a set of all possible input values. Now this one is, if you're looking at this graph is a little bit different because we're noticing that we don't have a straight line. We just have points on the graph. So our points would be, oh, here's one point here, one here, one here, one here. So we notice we have specific points, and this is not a straight line. Therefore, in this case, because the graph is not a straight line, the domain would only consist of the x values or all the input values on this graph. Therefore, in this case, it would be all the whole numbers that are at those points from 5 to 16. So it would be 5, 6, 7, 8, 9, 10, all the way up to 16. So that would be the domain of this function. So remember, it's only the whole numbers because this is not a straight line. What's the domain of this function? Now, as we look at this graph, we're noticing something different. You're noticing that there are arrows at the end of this graph. So if we think about it, remember we said that the domain is a set of all possible input values in the function. Now, the arrows on the end of the graph tells us that the graph continues indefinitely in both the positive and negative direction. We could say it continues to infinity. And so it would be all real values of x. So when you think about it, it's all values of x that go in the negative direction. So that goes to negative infinity. And in the positive direction as well, that will go to positive infinity. So it would be all real values of x. Now, let's talk about the range of a function. Just like we did for domain, we need to define the range of a function. So what's the range of a function? Well, the range of a function is the set of all possible output values. So remember, or y values are synonymous or the same as or output values. In this table, the output values would be 1, 4, 9, 16, 25. Therefore, the range in this table would be the values 1, 4, 9, 16, and 25 because these are all the y values that are shown. What is the range of this function? So we want to recall that our range is going to be the set of all possible y values or output values of the function. So in this case, we're noticing that it's from a low of -3 to a high of 6. Therefore, the range of this function on this graph would be all y values from -3 to 6. So remember, it's a set of all possible output values. What is the range of this function? Okay, so again, the range of the function is going to be all possible output values. Where do your output values start? They start at y is equal to 0. And those arrows tells us that, it's going to extend indefinitely in the positive direction because it's going up. Therefore, the range of this function would be all real values of y from 0 to infinity because we notice the arrows on the ends of the graph, and that tells us that the graph is going to continue to infinity in the positive direction, and it starts at 0. Okay? Now, let us apply what we know about domain and range to context. Did we get it? Let's see. Now, what is the domain of the function that is shown below? Do you recall? Remember, we said that the domain of the function is going to be the set of all possible input values. Therefore, if we're paying attention to our graph, we're noticing that there are arrows on either ends of the graph, and that tells us that it's extending or continuing indefinitely in the left direction and in the y direction, or in the so we can say in the left or the right direction. So we know that in this case, the domain for this function is going to be all real values of x. And we're saying this because we notice that it's continuing in the negative direction, and it's also going to continue infinitely in the positive direction. So in this case, the domain is going to be all real values of x. And again, we know this because of the arrows on the ends of the graph. What is the range of this function? Well, the range of the function is the all possible y values. So according to what we're seeing on this graph, we want to pay attention to the arrow. Or y values begin at y is equal to -1. But the arrow up top is telling us that it's going to extend indefinitely in the positive direction. So the range of this function would be all values of y from -1 to infinity. So it's starting at -1 on the graph, and because of the arrow, it tells us it's going to continue towards infinity, so it's continuing upward. Here's our last question for today. Is the value -2 in the domain or range of this function? What do you think? So when we look at this graph, what do we notice? Well, we can see -2 here. And one thing we're noticing about the graph is that this graph has no negative y values, which means there are no negative output. So it therefore means that -2 is actually in the domain of this function. The graph f of x does not have any y values that is below y is equal to 0. That means it doesn't have any negative y values. But there is one point on the graph that has an x value of -2. So it therefore means that the -2 is actually in the domain of the function, but not in the range. Hope this was helpful to you, and I hope you guys do a good job on your practice. Good luck.